Hello, hello? Hello? Is this thing on? Yo, what up? How is everyone doing? Good, I hope. So, I did a bit of work on the calculator PCB. Filled out quite a bit of shit in here. Let's see. The camera on the right thing, right? Yeah, so I've got basically all the parts laid out on this thing. And probably about half of it routed so far. Only other part that I have to do is the transformer up at the top of the board. That needs to be, I need to make a footprint for that sucker. I honestly need to figure out more about what it actually does, like the windings on it, on that transformer. And then I gotta finish routing some of the stuff. So mess around with that a little bit. And then I think I wanted to kind of mess with some of the jumperless code, the PIO code for glitching, hardware glitching. I was poking around with that earlier today, and I was able to get some results from the PIO state machine. So that's step one, and then step two is to actually get it doing what we want it to do, and then see if it's responsive enough for us to use. So. Let's see. Get some music. Do. All right. Hi, kitty cat. So I think what I was doing last was I was routing up the connector that I've got on the other side of this board. Kind of what we've got so far without the image. So, oh yeah, the other part that I haven't put on here yet is this weird resistor. I haven't quite figured out the value of it yet. I've measured it, but I don't know if I'm measuring it properly or if it's even a resistor. It's got 3 dots on it, 2 small orange dots and a big gold dot. But most resistor calculations are done with like 3 or 4 markings, 3-band or 4-band, even 5-band markings, and this one is most resistors are 4-band or 5-band, and this is a 3-band resistor. So it's kind of confusing. I haven't quite figured that one out yet. But This is what we've got. It's what we're dealing with, so I think I want to go ahead and fill some more of this out, some of these traces. Maybe see if we can get this whole connector going. Probably need to do some probing on the board to figure out where some of these are. Is that touching? That is a great question. Do not think so. Okay, so that's very tricky to see, but these are not connected. Little V right here, that's connected. These are all separate. All right. Let me see if I can make a hotkey for that. Preferences. Keys. Editor, break track. Cool. wonder if, probably should have looked this up a while ago. If there's a good way to make curved tracks. There's an arc tool. But I think this is just what, for making fillets? Oh. Interesting. So you can make it a fillet and then kind of drag it in and out. Okay. That's a possibility. Is there any kind of ROM storing operations, or is it hand-wired logic? I think all the logic is done in the integrated circuit right here. This TMS 0115NC. It's a calculator on chip. This little doohickey. TMS 0100. So this handles all of the keyboard matrix, bouncing, doing the display output, handling the 7 segment. So it's basically all done on this one chip. Which is my big fear, because if this chip is toast, then I'm not too sure how to get the calculator working other than find a donor chip. I could wire my own microcontroller into it. Alright, here, let's try this. Yeah, I don't really like that. There we go. I'll just put that back. I'll put that back the way I found it. What the hell? Oh, look at this one. That's a big one. Maybe I should make the footprint for this transformer, huh? Do. Oh, we want a through-hole transformer. 2x secondary, right? I think? I don't know. I just need 11 pins. None of these have 11 pins, I don't think. I got 5, 10, 11. Pretty sure that one is part of the transformer. I took some notes. As one does. But I can't find them because I don't keep track of them, as one also does. So we need 11. You do this. How big is this sucker? 37 millimeters. How big does our sucker need to be? 15. I mean, I guess I could just make my own, right? What's up with this grid? Makes me wonder why they make certain symbols the way they do. Is that fab? Yeah, that's fab. What is the fab layer for? Used to display simplified mechanical outlines of components on the PCB, including component values and reference data. Or for fabrication. Helps manufacturers understand the layout. Okay. I kind of assumed as much, but like, why you get that layer instead of like combining it with a different layer? I don't know, because you have like the courtyard, your silk screen. I guess silk screen's obvious because you don't want to like put all this crap on the silk screen if you don't need it, but let's see. I guess there aren't very many other layers rather than that one in most of these footprints or drawings. Alright, I'm just gonna make my own. Okay, let's go to custom, and we want to new footprint. Where'd the music stop? X15. And let's get a box in here for courtyard. Oop. this sucker, what, 15 by 15? I don't think that's right. Position. Right origin. Oh, wait. I can do that better. Shift P. Straight origin. This is going to be minus 7.5. But it's not 15 millimeters? Okay. Oh, you know, here, let's do this. 15. Now it's 15 millimeters, and then we can do Shift P. Use grid origin, offset. Okay, there we go. Is the courtyard supposed to be larger? What's the whole point in the courtyard? Smallest rectangular area that provides a minimum electrical and mechanical clearance around the combined component. Okay. So it should probably be larger than 15 then, because if the part's exactly 15, then we want to make it larger than that. 216. Right? And then Shift P, use grid origin. This is gonna be -8. -8. There we go. And this one is going to be fab, right? Yeah, so 10 divided by 5. Is that a 2 millimeter pitch? Let's see. If I can take this, Control T to array it, horizontal count, vertical count 5. Let's do 2 of these. Horizontal spacing is going to be huge. Right? Okay. Wowee, that's a lot more than I wanted. Vertical count is 14, it's supposed to be 5. There we go. I don't know how far or where that one is supposed to be. Let's see. Yeah. Just the right in the middle. All right. Is that what we're looking for? I have no idea what these windings look like yet, so I'm just gonna leave them plain. Alright, let's come in here. Add our new dude. Oh, close, but not really. Alright, so it's gotta be a little bit further out. What about on the other side? It looks pretty good. Our boundaries and everything. I mean, maybe a little bit larger than it should be. But probably just for photo reference. We can move things around. Measure this. What is our vertical spacing? And we're like 2.83 3 millimeters. What did I have it at? I had it at 3, right? Or I had it at 2? 3 will probably do it. What, 2.5, really? Okay. Third time is the charm. Looks pretty good to me, huh? Smacking into this sucker, but what can we do about it, huh? I do probably need to make it a little bit smaller. Let's see. I hit it, what, 15 before, right? Okie dokie. Right. I might hit save and it'll take forever. Okay. You should have seen what I was doing before I started doing it in KiCad. I'm just kind of keeping track of everything in an image editor. Mostly because I wasn't planning on getting this far, but it's much easier to work directly in KiCad, surprisingly. A little nitpicky, but it looks good. I want to kind of try to maintain the original aesthetic of the board, because you don't see traces like this anymore. Most traces are done at like 45-degree angles, just because it's easier for the process. So you can see like the tool automatically snaps it to 45 degrees. So it's a little bit tedious to kind of go through here and make them all curvy and wibbly wobbly, but I think the result is more true to the original board. Oh my goodness. This is a really curvy one. Oops. Let's see. We're getting there. Bottom side of this board's looking pretty filled out. Still got a bunch of crap up here to do. Mostly on the other side of the board, but backside's looking pretty good. Maybe get some battery leads. Are those footprints? We have footprints for a lead? Power? Supply? Or how about supply? Or battery? Not battery holder. This your blah blah blah. I'll just put a damn in here. Up. Oh, come on now. Well, that's a long trace. Okay. A little bit right up here. Very nitpicky. Do. All right. this trace gets super thin. It's kind of funny because all these other traces are like, I don't know, thicker. It's kind of fun, the variability in the traces on the board. Like, look at this. And then this one's all thick and blobby compared to that. I don't know, they're probably drawn by hand. They seem hand drawn or like hand masked. This device was made in the 70s, so whatever the common mass production process was, I think the original design was probably like hand drawn, and then they had like a stencil or something, and then they wave soldered the bottom of the board. And the only reason why I say that is because the whole bottom of the board is like covered in a layer of flux or flux residue. So I think they had all the through-hole components on there, and then they just kind of slowly lowered it into a vat of solder. But yeah, I think the traces are way too organic to not be hand-drawn. But it was a mass-produced or relatively mass-produced item, so I'd imagine they had some sort of stencil. Is that everything? Wowee. Might be everything on the bottom of the board. Impossible. There's got to be something I missed. There has to be. I'm just not seeing it. I will have to Control S. I'll stare at it while it saves. Or what'd I miss? Yeah, I think I might be good. Okay, now the tricky part is to flip this sucker over. Start getting all the traces on the other side. Because right now those are kind of hard to see. Here, let's I'm gonna turn off. Turn the courtyard back on. Front sheet? No. Let's just turn off the courtyard. And then we will save preset as front. Gives a little bit more visual acuity. We're digging with all this crap. Probably want to turn that off too. So we're gonna work with the front layer only, which are these red traces. And let's start knocking some of this stuff out. I'll probably have to refer to the board quite a bit on this side just to confirm what I'm looking at, you know? And make sure that there aren't any other traces that are being missed. Like, see, this one's kind of hard to see, but it actually goes like this. Oops. Actually, this might be a good opportunity for the filet. The filet mignon. Let's try it. Oh, because there's another, huh? Whoa, whoa, whoa. Oh, that's so weird. I don't know, whatever. Good enough for me. It's not as, like, curvy or organic as the board trace, but close enough. Oops. That's going to this guy. Is that the... No, okay. I thought these were same leg. Oh yeah, I don't have this part on here. This thing. Yeah, I was like, wait a minute, this hole's not in the right spot. Duh, because it isn't. Dingus. Okay, so this is going up to that cap. Oh, it's actually passing through. Going all the way to that. Oh, what a goofy trace. This is, yeah, this is, the backside was easy. This is going to be the tedious one. I promise this is what this trace does. I swear. Yep, that connects all that crap. Goes all the way over there. Wow. Okay. There we go. That's a gnarly one. It is going to that one, right? Yes. Okay. Alright, we may need to refer to my original effort to figure out what these are. That I'm gonna go and retrace all of them. Let's see. That was the sucker over here. Where's my clock at? Segment driver. Oh. Guess I don't have it in here. Well, guess it's time to get probing. It's just a single board so far. There's a couple other parts to it. Like for instance the display PCB with the VFDs on it. So this thing has its own little PCB, but it shouldn't be too difficult to do this, and I may not even need to. I will though at some point, but for troubleshooting purposes, I shouldn't need to. And then there's another PCB in here for the key matrix. All the little read switches. I'm also not sure if anything on this board is bad. I'll probably want to check that at some point. I'm not sure what, or if anything on this this PCB would actually cause it to not work. But as far as I can tell, there's no clock signal on the chip. I've got voltage across the board in various different places, so it seems like it's powering up and it's doing something, but the VFDs don't turn on. And I don't see a clock signal on the integrated circuit, so I'm not quite sure what is stopping this thing from working. Hopefully it's just not the integrated circuit that's busted, but so let's get some probes and start doing some continuity testing. See if we can't figure out what these pins are. Let's see if this will work out for me. So let's try and figure out what number 19 is. Where is 19 going? Maybe easier to actually, yeah. Just one of these little grabby dudes. Okay. And we'll do that. And I think we'll really just start probing some of this stuff. Looks like we got a couple pins over here. Nope, just one. So that's gonna be... What is that? The... Oops. Put that back on there. These are where my little clips are forked up. So second from the right, 27, right here. How does that get to there, though? Is that... Eh. Is it going underneath the IC? Oh, yep. I think. Oh. I think it's like coming over to here. Oh, is that it right there? No. Oh, I guess it is. Okay. Okay. It's this dude right here. Right on the top. Go back to... Oops, sorry. The further on the right layer, the front layer. We're gonna do... I think it comes to here too. Let's make sure it actually... Yeah, so it probes right there too. Right, and then this comes down here. Just one of these doohickeys. I can only imagine what it looks like under the board, under this. We'll have to make sure that as we come over here and we start laying down top board traces that we don't have any red lines overlapping. Like these. Alright, what about pin 20? Pin 20 is connected to that one. It could be connected to other stuff, but let's see what see if we can figure out what these others are connected to. I want to see what number 9 is connected to. Go ahead and do that. Oh, that was easy. Number 18. Right here. Alright, what about the next one over? What about you? Where are you going? Are you next door? Oh, you're down and to the left. Okay. And then next, right above that one, number 16. Cool. Gonna save that really quick. Okay. And then we got number 6. I'm guessing number 6 goes to 13 right here, but I'm gonna test it anyway. It's that one right down there. This one's kind of hard to get in there and grab. That had to go between the legs of the capacitor. Alright, what'd I say? This one's probably number 13, right? So 4th from the bottom, right? Yep. That's the one. So this. Okay. Actually looks like this curves up a little bit. We want to get all nitpicky with it. That's okay. Cool. Oh, I hit Control S. Now I can wait an hour. Alright. Looking pretty crazy. You turn off this picture, it looks pretty cool. Still got a bunch of stuff to wire up though. Okay, so I'm gonna guess that most of these only have, if at all, one wire going to them, which means that we've only got, what, number 3 and 5 left? I am not sure where those would be going. Or coming from, at least. So that might be a tricky one. Let's try this. Is it 3 and 5 are these guys? Oh, these are the, no? Oh, is it connected to the VGG? Is that what that is? What the hell? Why this transistor over here? Or MOSFET? That goes all the way up to this, the transformer? Is this the power switch? This is the power switch, isn't it? Bro, why is that so confusing? Okay, hold on. Is this the switch? That is the switch, isn't it? Pretty sure. So 2 and 3. Did this a while ago. Let's see, let's clip it to... I'm not sure. Not a very good spot. Let's get back to the, probe. Okay, so this top lead is 3. And this other one is 1. Wait, and then 3 was also going to the MOSFET? Was I reading that right? So this pin comes over here to the MOSFET. The drain, right? The drain on the MOSFET? That's interesting. It's coming over here, touching this, somehow. I think that's because this is all the same power rail for, what is it, VGG? This one goes up to ground, or is that... Oh, that's the ground rail. Wait, no? This is ground rail. What the hell is this one? Hmm. Okay. So if 3 goes to the power switch, if 3 is going to the power switch, what the hell is 5 going to then? Because 3 and 1 are power. That's for the switch on the front of the case. And then we have an extra one. Just gonna be this guy. I guess we'll probe around and find this one. Nothing yet. Is this one no contact, or not actually touch anything? What about here? No. Wow. Nothing, huh? That one truly could be no contact. Not actually touching anything. Yeah. Maybe. Let's try something here. So set that off to the side. I want to connect this. And we're going to probe. I'm not sure. To be honest, I'm a pretty new to KiCad. This is my first PCB that I've like reversed in KiCad, so I'm not sure if I can take this and like go straight to like the schematic, like have the nets in the schematic view. But I've already broken some of this out into its own schematic. So what I think you can do is you can I think you can break out complete nets, like highlight nets in this thing once you've got it like simulatable. And then from there you can kind of reverse engineer the schematic a bit easier. And you can also label your parts too, so that it'll kind of keep track of them. You have reference names for them or something. I don't think there's any like automatic like schematic building though. I think there's just like ways that you can use this to kind of analyze it a bit easier. keep track of stuff. But I could be wrong. Like I said, this is the first board I've reversed in KiCad. So if that thing's no contact, I'm thinking it's part of the power switch. So right now it is off. So we should have no contact between 1 and 3. Then we set it to on. And then we've got continuity between 1 and 3. And then still nothing for pin 5. No continuity there. What about if we have it off? Is there continuity? No. So maybe that pin is no contact. I don't know, I don't see anywhere that it's being used yet, so... I could desolder the connector. I don't really want to do that though. The thing's already not working, so... You know, actually... Let's check. I'm gonna check this diode really quick. Where'd it go? This one? Is that the right one? Yeah. Huh. That one's not actually, reacting properly. There's a, so just for testing, I've got, let's see if I can get you guys a view of this. Still trying to figure out where in the circuit it's actually not working. Like I said earlier, the clock circuit, I can't probe the clock circuit and get anything off of it, so that's kind of interesting. But there's a little Schottky diode in here. You might be able to see right there. And normally when you test a diode, there's another Schottky diode over here that I'll test, and I'll show you what this looks like. So I've got my meter in diode test mode, and depending on the polarity of the diode, you'll either get infinite resistance, and you'll just see a 1 on your meter, or you'll get the forward voltage of the diode. So if you see right here, my meter is showing 7.98 as the forward voltage. And if I swap the probes around, reverse the polarity, you'll see it goes infinite resistance. And we get nothing on that end. So if I come over here to this diode, that's, what pin is this off of? This is off of the E11. E11? Because we've got it like that. Yeah. G11 pin 13. Okay, I have no idea what that's for, but so let's test. Make sure that I'm getting the right one. Okay, I may have just been testing the wrong pins, but these two leads right here, we've got infinite resistance right there, And then let's test opposite way around. Oh no, okay, that one's showing 4 voltage. So I guess I was just testing the wrong pins. False alarm. Man, I thought I figured it out. I was like, oh, cool, bad diode. Easy fix. No. This dude does look like he's gotten pretty hot, though. If you look at the MOSFET that is unused that I have, how nice and shiny the metal is on that one versus this one. Looks like it got really hot. So maybe this sucker's bad, who knows? Alright, so I think 5 is a no contact or no connect. Can I mark it as no connect? Or I guess I just leave it like that, huh? And this one goes to switch. Alright. Which one is this? I think 3 goes up to here on the other end of this weird thing, which I still haven't figured out. I think it's a resistor, but I'll just put a resistor. I need a really big resistor anyway. Let's see, from here to here, it's like a 5.9. 5.5 millimeter resistor or something. Shit. What? Oh. Oh, oops. Oh, damn it. Screwed that up. There's 6mm. I know it's not 6mm, but... Oh! Never mind, it is. Okay. Hope that didn't fuck everything up. Oh, so close. All right. Here we go. Alright, it's been a minute since I've saved, so let's let it lock up for a second. Hey, if this gets too boring for you guys, don't forget you can send commands to this breadboard. My code is still working, that is. Oh no, of course not. Yeah, you can send cool commands like 8-ball. You can ask it questions. Let's see if this one works. Oh, I gotta reverse this. There we go. Whoop. So if you check out the description, there should be a link to the MicroPython API for the jumperless. And you just prefix any of those commands with an exclamation point, and it should send it to the breadboard. The exception of commands, but wow, do I really have everything back here connected? All right. All right, let's inspect. Oops. Let's inspect to make sure that we're catching all of this stuff. Yeah, so these are all connected like that. We've got this one, that one here. Go into that pad. Yep. Wait, let's go into this. Interesting. Interesting. So this thing... I can actually see the trace going through... Yeah, I can see it go, kind of hard to tell, but it goes like here to here? Right here. Yeah, you see right there? There it is. Pretty sure that's the store handy dandy probe test. That's the middle leg on this sucker right here. Yeah, because I think this is kind of like a power rail. It's probe again. Maybe grab this leg. I may have fucked up this grabber doohickey. Ah! Yeah, I've screwed up that thing. Hello, kitty cat. Alright. There we go. I think I've got it now. So, I believe... Yep, that is connected to this pad, which means that it runs up this, EGG rail? Where is it? EBB? VSS? VSS. This one right here. Okay. So that's connected to VSS. But... Oop, no, we want front, not back. But it's connected like that, so... And then it goes... Which makes that also connected to this one. Like so. Alright, and this is VSS, right? Yeah, VSS. Cool. So that makes sense. Come over here and... Oops. Make these a little bit more, respectable looking. Nice. Alright. What else are we missing on this top half? Oh, that's right. We don't have any of the damn pins for these suckers. This is where it might get a little tricky because it's kind of hard to see in there. Here's my other photo. Makes it a little bit easier. No. It's still kind of hard to tell. The VFD segments multiplexed or driven individually? I believe they are multiplexed. based on the, let's see, there's something in here in the docs that showed it. I guess they're not multiplex because they have a pin for the segments are multiplexed, I guess, because it's got segment drivers. I just want to read it somewhere in here. Let's see. Here you can see this is the display schematic. And these are all the individual segment drivers that you can see right here on the back, at least what's labeled. These guys right here. This is the segment driver section. And then I believe these transistors switch the higher voltage from the transformer to the displays. And then these are connected to, what is it, the display segment pins, I believe. Those are these guys right here. And I think this actually is what controls this, or what carries this signal. Honestly, I'm not entirely sure. So I'm not super familiar with how this calculator on a chip is doing all of this display driving. I wish I knew, because then I could fix it and I'd have a cool calculator. Right, so this one, this guy right here, goes right there. 1, 2, 3, 4, 5. 1, 2, 5. Okay, cool. Double checking. It goes to here. Okay. It's all of these except for, what is this one? Or this one right here. Where are you going? You're on the back side of the board, aren't you? Okay, so you're going right there because of that. Gotcha. Is it actually connecting? I don't think so. That was an erroneous connection. Doot, 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 doot. Alright, cool. Got that one. No, what's connected to that one? Nothing? Okay, so that's nothing on the front side of the board. Right. I'm gonna save it. I'm gonna take a quick break. Just a couple minutes. Go grab some more drink. Go to the bathroom. I will put the camera on the breadboard. You guys want to mess around with it while I'm AFK? And I'll be right back. Okie dokie, I'm back. Let's see. Let's do this guy. I think this is our pin number 1, right? Or no, number 3. Yep. Oops. Just like that. Right? second one goes down to where? Let's go down to this one. Hey, what's up? How's it going? Where is this first one going to? Oh, that's this doohickey, this top rail. Got this guy going like that. Yeah, there you go. Oh, there's a lot of stuff to connect up over here. And it's all kind of hard to see. This doohickey. What about number 3 over here? He's going back over to this guy. Like that. Okay. And then I think that's connected right there, right? Yeah. It's a little Schottky diode. Got traces look a little goofy over here. They're very hard to see. But it kind of goes like this, that, and those two are not connected. So we've got this one going back over to here. This middle guy goes all the way over to here. Or is it down here? I'll just do it right here for now because I'm pretty sure. Actually, let me just probe it. It'd take 2 seconds to grab onto the leg and hit it with the multimeter. Alright. So my lead fell off, but I kinda got the gist of where that one's going. And I need to get some better clippies. What clippy do does. Okay, so the top two are no connect. The second and third, or the third and fourth. The top two are no connect, third and fourth are connect. So I think these are actually bridged on the top half. like this. And let's make sure, is this the middle leg on the bottom transistor? Yes. And this one looks like it's going directly to number 9. I do like to check though, because they can be misleading. Just get our little grabby in there. That. And test. Ah! Alright. Please stay attached. Thank you. And then this one is going to number 9, right? No? Huh. You see, that's why it's always a good idea to check, right? Okay, so this... Wait, which leg am I connected to? Am I connected to the... No, it's not the middle. Okay. So I am connected to this leg right here, number 3, on this doohickey, and you would think that it would be connected right here. It kind of looks like it, right? It actually comes like this, and goes doo-doo-doo-doop, right past all that shit. So, this guy looks like this, like that. And these are both connected somehow, I think. Yeah, so it's not connected to pin 11. Connected to this thing right next to it. Pretty sure. Yeah, I think that's what we're looking at. Alright, the middle leg on this guy. Is running back towards this one. Following this little trace. Very, very tiny trace. All the way up here. Oops. Oh, come on now. Don't be like that. Whatever. I'll fix it in post. Oops. Hey, there we go. Kind of making sure all these pins are connected to something. They all look pretty good. Yep, that looks good. That all looks good. These two are connected. Okay, the outside ones are connected, like so. That makes sense. Alright, I think we're... Wait, what's connected to one? Is this connected to one? That one right up there? Yes. Ooh, almost forgot it. Nice. Right. Then let's move back over to... Actually, we got some shit unconnected over here. Here are kind of some easy ones. I think. Should be easy. This is via to via. We'll be a little bit pickier and make sure this doesn't actually run into that. Does it curve like that? Yeah, actually it does. Okay. There's a little doo-doo, a little boo-boop. Okay, this one's going to the first middle leg, all the way over here. This guy right here. Alright, that looks pretty good. A little bit steeper. That. Nice. And then look at these. These all go to these various different transistors over here. And it looks like they're all going to the middle legs, because those are all feeding the base, I believe. That's the base pin. Or the collector. That might be the collector. And it is sequential until we get to... weird after the first 4. And we can just do this. 1, 2, 3. This one's a pretty nice, I might actually be a good candidate for the... what is it? Fillet. We'll do this. Do that. Select these two. Oops. Click. Play tracks. 1mm. Perfect. And that one looks like it just goes straight down. It actually curves a little bit to the left. Just like that. Okay. And this one was a little weird. It comes down like this. And going like that, where does it go? Let's go to, I think 1024. Let's find out. Oh, cannot grab this leg for the life of me. Probably already come off. Let's see. Nope, 7. Which one is this? One, two, three, four, 5. 5th from the top left? No way. I grab onto the wrong one? Make sure I'm grabbing the right one. Okay, this guy. Okay. Now let's just actually touch the stuff up here. Yeah, that's what I thought. I thought I did something wrong. That didn't make sense for it to go from here all the way over to here. That goes to this one right here, 24. Which is pretty obvious in hindsight. Five to 25, you think? Nope, nothing. Yeah, I think it's just, I think these are all one to one, like one pin to one pin from this transistor array. So this one's probably got like the middle pin going down to 26, right? I'm guessing. Oh, see, 25 is the one to the right of it. Or sorry, 23. 23 is this one. So this one goes all the way down here to 23. Why it curves like that? Wait a minute. This one goes to 24. Shit, I got that wrong. This one goes to 24. This one goes to 23. This one probably goes to 26. Okay. Yeah, I'm offset a little bit. That's okay, we can fix this. Just delete this. Delete that. Do that. I was wondering why that was weird. It was weird. I'm guessing this goes up to 3? Yep. There's a little squiggly thing though. It's not... No, it goes up to 4, sorry. It goes up to the 3rd pin. And it does this thingy. Like that. Wow, really? This one goes all the way over to here? Wait a minute. I'm not there yet. I'll wait for that one. And it takes a while for this thing to save. Okay. Yeah, let's get the rest of this one. I think this one is 26. That did not stick. Okay, and so this next one is down here at 25. This guy goes down to 25, and is the one next to it 26? Wait, did I just probe the wrong one again? No. This one should be 26, no? Wait a minute. Okay, here, let me just do this. This might actually be easier. Let me do it from the back side. Untangle my damn cables. Alright, so starting from the one all the way over to the right, which pin are you? Oh wait, sorry, I need the middle one. So you are that doohickey. You're 27. So this guy goes to 27. All right. And then middle pin on number 2, 28. Middle pin on number 3. It's the bottom side, so we're on 25. Like that. 1, 2, 3, 4. So number 4, middle pin goes to 26. Like so. And then number 5 goes to 23. Which one's number 5? 1, 2, 3, 4, 5. Middle pin goes to 23. And then 26. Or sorry. Number 6 goes to 24. Correct. Okay. Alright, that's these 6 pins sorted. Let's fancy these suckers up. I can only imagine that it's a nice sweeping smooth line under there, not no jagged anything like this. There's not a single 45 on this board, I don't think. All right. It's wiggly. This whole board. That looks fun though. It looks like it's hand drawn. Alright, so what about this? What about the second one over here? You are going all the way over here. Holy crap. Right, which one? We've got 1, 2, 3. Third transistor from the gap. 1, 2, 3. So this one is going up to number 3. Number 2, sorry. Yeah, number 3. And this guy is squirrely as heck too. It's like this. It does like a zigzag. Just move this one a little bit, because I bet you this one is not that close. There we go. Good enough. And then this one goes to the one right next to it, right? Yes. Correct. Doesn't hurt to check. Oops. Wee! What a mess. I got some stuff to connect up here too. I think all these gotta get connected. There's like a handful of these that are unconnect. No, not connected. Yeah, turn off footprint maybe. Let's see. I'll get rid of my pads though. Why you do that? Damn. Can I just add notes in here? Cool. I might have to do that at some point. It's not too bad. The footprints aren't crazy annoying. Oh, here, I can turn off, oh, that's what you're saying in the selection filter. My bad. Totally misunderstood you. Yeah, right here. No, I'm not accidentally clicking on them. Thank you. So let's see. We've got this wired up. This guy goes over to the middle pin, right? Yeah, this is the feed. Just go into our middle pin right over here. There we go. This is connected on the back side of the board. Where's this going? Number 3. You're going somewhere. Might be, probing time. It's probing time. And then I started probing all over the place. Alright, goes right here. Ugh, God, these clips suck. I've ruined all of them. Get out of here, crappy clip. What about you? Are you less crappy? No. Alright, well, it grabbed. Unlike the other one. Does that not go to the not grab? Or does that not go to one of those pins? Holy crap. Ah! Is it really going in this through hole right there? Okay. Alright. Through hole via, sorry. Oh, I guess these pins are all coming off of this sucker right over here. The segment drivers. Okay. What else? Do I have everything connected up here? This dude isn't connecting. That one is pretty obvious, going right to there. And this is going to here, right? No. Okay, so that's not connected. That's going to here. All these pins are connected. Those are connected. Got everything over here connected. Yep. 18 isn't connected. Where does that go to? Is there anything connected to 18? I'm not seeing anything. Not immediately. $18 is going to be this guy right here. And we'll just go ahead and lightly graze the board, see if there's anything connected to it. I don't see anything. Well, oh, nope. Yeah, I think this is a no connect. Okay. These might be no connect as well. Not the bottom half. Actually, no, these are probably connected from this sucker over here. Let's get this one going. So number 9. Actually, we're gonna have to do, we'll just do what we did last time. Do it from the other side of the board. And just go one by one. And 3 of the last 2 transistors not connected to the other. Oh, these over here? Or this one right here? Yeah, I don't think I've got that one marked. Where does this one go? This one kind of goes over here. Or if that's all part of the same one. Oh, I heard it for a second. This guy. So this one, let's see, is going to... fourth pin in, so... this guy right here. What a weird one. This was the pin that you were talking about, right? Because it was definitely not connected. Good eye. I've been wondering why my schematic didn't make any sense. Alright, so we got that pin 3. This pin 3 is connected on the back side of the board to pin 3 on the IC. That one's connected on the back side. That's connected on the back side. One's connected. And then let's check this one. Those are connected. These are all on the same rail through the back side of the board. Pin 3 is connected there. Got all those connected. I think that's probably good. Alright, for this sucker, I think I want to start from the innermost one, so number 9. And let's see where that goes. I've got number 9 right here. I believe this goes... Okay, so this is the 1, 2, 3 from the inside on the bottom, so number 13. 1, 2, 3. And I'm guessing the next one over is the one right above it, right? So number 8 on that resistor network, not above it. Which one are you? On the right thing. What the hecky? Hello? Nothing? What do you mean? What do you mean none? That doesn't make any sense. Oh, this one goes somewhere else completely, right? But there's also something on the board? I'm confused about this one. You'd think it'd just be right there on the connector, right? Oh. It's just not... I'm not punching through the flux. I'm not punching through the flux with my damn probes. That's crazy. Okay. So it's the one directly to the right of it. As you would suspect, the way this shit looks. Alright, just to confirm, I wanna go through these real quick. Okay. Alright, this is the middle one, should not be that one. Is it? It's the next one over. Yep. Yep. And then that very last one. Where do you go? Right above it. Okay. So I should be able to wire all these. One goes like so. This one. So. And let me just organize these a little bit before I start getting confused. Oh, rip. Code broke again. Hey, 8-ball, will my code ever work properly? It is decidedly so. You're a liar, 8-ball. 8-ball don't know shit. This song makes me think of Mux Mool. I don't know if you've ever heard of them, but they're pretty good. Alright. Cool. Consider that wired up. Got these doohickeys. Oh, this guy's actually going into something? You going into number 4 or what? What are you doing? Let's see. This resistor right there. Could that be going over to this thing? Where is that going? Oh, right below it? No. Yeah, I don't know where the hell that's going. This thing is connected to a mystery. Let's find out what the thing next to it's connected to. Let's see, where did my thing go? Right, and middle leg on this guy. Come on. Bruh. Alright, so this goes to 6, right? I'm guessing this next one goes to 8? Okay, so that's the one that I just probed. Doing 3, and then number 8 goes to the one next to it. Number 7, the one next to it. And then not that one. Okay. And then what about the one after? No? Okay. So this guy goes to here. And this one goes to here. Alright. They're connected. What about 14? Oh, that was the other one that I tested. Right? Because that one's connected on the back. That's skipped. And then 14. In from the gap. Where's this one go? That's 7. 6, 5, 4, 3, 2, 1. Nothing. Is this like gonna be a voltage rail or something? ESS, ground, right? Oh. How does it get from up here all the way down to there? Is that VSS? No. I do not know. Well, that's not helpful. Man, I wish I had taken photos of that when I took those capacitors off. It's hard to see under these. Wow, no way. Holy shit. 14. And 14 goes all the way over here. That's this sucker right here. What the heck? I see. It's going to that through hole. So it's going to this, and then this goes to 14. Interesting. I don't think this is right. This capacitor's throwing me off because I can't see underneath it. Actually, okay. I see now. This one. This one does not actually connect to that one. This one goes like this. I think? Wait a minute. Is this right-hand one? Doesn't touch the left, goes through. That one doesn't belong. There we go. Okay. I believe that is correct. Alright, gonna save it really quick. I see you over here not connected to something. Number 23. What are you going all the way over here to 12 or something? Let's see. What are you up to? Number 12 is... nothing. That's that guy? Oh, okay. 23. You. And with me all the way over here. Like so. You're gonna connect right there. Right? about this one, number 3? Where are you going? I don't have you connected anywhere, do I? Where the heck do you think you're going? So you are going to number 12. Okay. Whatever, looks good enough. Alright. Let's go into 12. I think we've got all of those connected. To something at least. Check all our pins up here. They all look like they're connected to something. Number 5. Oh, that was the no connect that we determined earlier. At least for now, until proven otherwise. Wow, is that everything? No way. I refuse to believe it. Alright, 18, where are you going? Are you no connect as well? That was, I think that was the, or was it 14? No, 14 was that one all the way up there. These are all connected. 18 is not, though. I think that might be it, with the exception of 18. Maybe we can probe around and see if we can find out where that one's at, if it's anywhere. This guy. I'm not seeing anything. Well, the multimeter isn't seeing anything. Yeah, this one might be a no connect. Okay, wait a minute. Yep. I'm gonna say this one is a no connect. Until proven otherwise. Maybe that's like, no? Because I was gonna say, if it was a ground for like the VFDs, the display, then it would show. Cool. So that should be. Should be the whole thing, right? Alright, let's do this really quick. We've got 77 millimeters by 70, I think it's 7 or 76 millimeters. Extra millimeter on all sides. So probably not enough. Ooh. Okay, whatever. Oh, I should have done this as edge cuts. The layer edge cuts. Right? Edge cuts. Climb on. Then we can do circle right here. How big's this sucker gotta be? ID of 5.75. Wow, no way. My shit is all out of whack. There's no way. Did I measure that right? 5.8. 5.75. Computer, scale everything by 3%. Holy shit. Well, that's not gonna work, right? That doesn't make any sense. Oh, is that... That's, like, total diameter, not, Wait. That's radius. Oh, okay. Computer, what's 5.75 divided by 2? 2.875. Jeez, okay. Yeah, I was like, there's no way my shit is that off. Holy crap. Okay. Is that right down the middle? I guess that's right down the middle, huh? Oh well, I'm not too worried about the precision of it yet. So, because this image is not to scale. It's not an appropriate scale, but it's close enough. I'm gonna save this. Alright, you saved? Okay, cool. Hey, what time is it? Alright, I'm gonna go take a break for a couple minutes, and when I get back, we'll try to see if we can map these as nets. Over here, I think is what we gotta do. Set these up as nets, and then we might be able to translate that back into the schematic. If anything, we can come through and we can start labeling these with reference numbers or reference names. And yeah. I think we're getting there. We're almost there. It'd be nice to figure out why it's not working, but I don't understand enough of the circuit to determine why yet. So that'll have to wait. Maybe I can. Let's do that with the nets. Once we start pulling the nets out, we have a schematic of like each section, like the segment driver section. We can have a net of that, and then the rest of the stuff or whatever. I don't know. We'll figure it out. But I'm gonna go take a break, go to the bathroom, refresh my drink, and I will be back in a few minutes. Okie dokie, we back. See, 4 in range. I wonder if I could do a list comprehension. Let's see. Do boop. 4i in range. I don't know what, 3? Does that not do anything? Okay. Guess it doesn't do anything. Alright. Enough messing around. Alright, so I've got to put together some nets. I think. Okay, so what about 15? What is 15 connected to? Is that connected to anything? Is 15 also a voltage pin or something, like a ground maybe? The VGG, the reference ground for the cathodes. All this crap out of the way. So which one is it? If we're looking at it like this, a second from the inside, or a second, yeah. Is this one? Who are you connected to? BSS? No. BGG? Or ground? No. BGG? No. That is? No. I don't know. Okay, what is that? That seems to be connected to it. Okay, that's this guy. Backside of this guy. Oh, so is that how this thing is running through here and coming to this? 15? Oh, tracks copper layers only. Is that also 18? No, that one's 14. Okay. Sure. Okay. Do, 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 do. $18 is still no connect for some reason. I don't know what that would be. Is it this? That go to here? No. Because that's going to 24, right? There's, okay, hold on. A couple fingers on this thing that don't actually have anything on them, so is that 18? Oh no, but that's funny. Interesting. Does that mean that's not actually doing anything either? These two? 17? Oh, you know, I bet you it's for different displays. I bet you it's for a different type of display. Check this out. You can see it. The gap in this right here actually prevents pin 18 and pin 17 from connecting. So when it's actually joined up, there's not really a connection on the PCB or on this finger that it's actually touching. So that's interesting. But 17 has something on it, so I think maybe 17 is... What is 17? Does that go anywhere else? No? 17 looks like it's the output of, or not the output, but a, in on one of these transistors. And going over here. Oh, this is the, I think ground. For the clock circuit. Alright, well, let's try building a net. I don't know how these work. I haven't messed with that before. Oh, I can do filled zones? Interesting. Wait. VS. Right, which one is that? Oh, VGG. Right? Yeah. Wait, can I make a new one? Or I have to have a... Figure out how this works. Board setup. I have to add the nets in here. Yeah, net classes. Default. Wait. Oh, these are for lighting. Okay. To the internet. Oh, okay, so that is what that is. Good names, nets, set up net classes and their dimensions. Ah, okay. do I not need to do that? Hold on. Okay. Yeah, do the schematic first. That makes sense. Once you have a schematic, you also have the net list. Yeah, that makes sense. And then we've got G and D. And right, BSS, VGG, and ground. What is that? TDI? No idea. Right, well, let's go ahead and save this. And it takes its time, sweet time. Okay. So I guess I need to probably start going back into the schematic and figuring these out based off of what parts we have. So I guess set the footprint for these two. Oh, see, I've already got it. Okay, cool. Those are already custom wide squat prints. So the clock circuit is down over here. And this whole doohickey and this doohickey. So these guys, oh geez. Oh, I need to footprints. create, edit, and delete footprints, was it? Oh, is it only in here? So it's connected to the output register. They're both connected to the resistor. Can I do this now? Now that I have a... No, because I don't have any nets. Shut up. New net. Net name. Let's see, GG, right? Nice. Cool. Does that indicate just like a huge plane of copper? Or like a huge section of copper for this net? Rule area, keep out. Okay. Okay. Gains no items with label nets. Okay. Whatever. Figure that out later. Piece view changes made to schematic. Let's save this really quick. Okay. That's a potential issue, but that's fine. The lyrics. Okay. I guess I can start to label these guys, or maybe... Okay. Of course, I put the wrong one in. Right. There we go. Get out of here. Be gone. Okay, so how does this work now? Only annotated schematic. Alright, let's try this. We'll start with... I think this clock circuit is good. I think I've got that one figured out. So then I guess, we've got these pins. They're coming off the D345 through 10, 11, and 12. What are those doing? 13, 14? 13, 14 is VDD. Okay. Okay, so pin one is the. Is that go? Let me just double check this really quick. Oh, that's actually bridged right there, isn't it? Yeah, I've got that. No, I haven't done update schematic from PCB. I don't think that's... I looked and I didn't see it as a thing. Maybe it's in here somewhere. Tools. There's update PCB from schematic. Oh, there it is. Schematic from PCB. Okay, cool. So let's see how this works. Relink footprints to schematic symbols based on their reference designators. Relinking footprints requires a fully annotated schematic. Okay, so there's a lot that have no assigned symbols. I think I probably need to fix that, right? Yeah, nothing's got assigned symbols. Interesting. Okay. Let's see, so if I just grab this thing, where's this symbol? Or is that gonna be in here? Like... Notion doesn't have symbols. Okay, hold on. Library footprint. Do I need to do that from the footprint itself? Let's see. Footprint editor. Properties. Is there a symbol? No. This is all the same shit. Oh, do I? No? Oops. Footprint defined inside the symbol properties. Oh. So, come over here and I edit this. Yeah, it's got the footprint custom TO92 wide squat. So do I guess I need to do the same thing for this one? Print custom axial. Okay, let's go into here. And we'll set footprints for all these mofos. Oh shit, what I use? Right, you guys, where do you erect? Wait a minute, C1, B, blah, 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 blah. Oh, see, these are actually different. Shit. Wait, oh no, because these are all C-polarized, but these are squared. They are different sizes. These guys right here. Do I have those as a custom? Do that for now. Let's see. Oh yeah, this is the shit up over by the transformer. This one connected to 3.3K. Probably not the best way to specify the value. Wait, no. Okay, yeah, that is value. I thought I was changing the name of it. Reference. So VDDN Wait, where the hell is VDD? Pretty sure that's over here. Yeah, I just kind of want to redo all of this crap, so... Because this stuff is definitely inaccurate. I mean, isn't. The footprint for this one is capacitor? Oh, I did that wrong. Oh, I did do that wrong. That's funny. Yeah, that's... See, this is why I kind of want to redo this. Oh, kind of a mess. Alright, I'm gonna dunk on this shit. And... start over. Whoa. Oh, wow! Can you do that in the PCB editor? That goes hard. Right, what are these? Let's go start testing some resistance. I think these are all 100 kilo ohm. So center pin. And one of these gives us a capacitor. Oh. 240 kilo ohm? right there? I mean, it could be. Let's see. I mean, I can't really see it. Alright, what about this one? This one is 220, 220, and where is it? Where's the middle one? Right there? $102. Okay, so this is interesting. I have to figure out which one of these is which. So this one coming directly off of these segment driver pins, right? Those are the segment drivers. Somewhere in here. Holy crap. Where is it? Ah! It's just on it? Wow. Yeah, so these are the segment drivers. That's this one right here. That was a 220. This one's a 200 and, or this one's right here's a 220. Value. I guess it doesn't need to care about the value of it over here. As long as the footprint is the same. So, but this over here, I can set the value at 220K. And this is RN1. So if I go back to the PCB, because that is RN1, and I save this, is it? Oh, it's gonna be fully annotated, right? I was curious if it'd let me update from the schematic. Wow, this looks like it's gonna do some stuff. 2 errors. Connect pin 5 to that net. Oh, see, that's not right, though. RN1. I thought it would update that. Wait, maybe it does. Changes the name of... What is it? Something RN whatever to... Okay. Oh, the footprint. I need to set this to something dip, right? Dip 21? I don't know. Yeah, dip? Resistor THT RA SIP9. That's not the right footprint. That's... I'm using this one. I made a custom one. For the center common. Oops. Custom. Yeah, this doohickey. There we go. I'm gonna do that to all of these. Okay, so this one... A749 base. Is that... What the fuck is that? Why did I name it that? I don't know. Okay. BGG A749 base. Oh, wait a minute. Where's the BGG pin? BGG is this bottom right one. This guy right here. What the fuck are... What was I smoking when I did this? What the fuck is that? I'm just gonna fucking delete this too. Yeah. These capacitors are these guys. Oh yeah, the C-Rect. They should all have that now, okay. Alright, and then we've got custom white squad package dip. Capacitor. What is this? One five. I just do one five. Doesn't really matter. So it's gonna be 3K3. K7. No fucking clue what that is. And also no clue what these are. They say 101J. Something else. Can't really tell. SE. Let's check. 101J SE ceramic. It'd be like this. Like a picofarad capacitor. I don't really have an LCR meter. Plus I'd have to pull it out of circuit, I think, to test it. Okay. I'll just say it is a 100 picofarad. Got a Shocky or NPN C41. Okay. Let's save this. Now let's go over here and try this again. Well, that's a mess. I don't think it did that right. Oh, look, we got our hotkey all the way over here. I guess it's like a leftover hotkey or something. Oh, you know what it is I think this is... I need to set this as a diode. And then... I think that might do the trick. Because that was R6 or R7 or something. What is this? R2. Oh, that's an R3, R4, 5. This is R6, isn't it? This should be R6. There we go. Then I think that'll... No? Huh. I think because the schematic hasn't been built, it's not populating the references over here in the PCB. I don't know. Dude, this is R6. Or is it saying that there's an R6 and an R7 over here? I don't see an R7. It's crazy. Okie dokie. Well, I think this wraps it up. I'll have to do a little bit of reading and figure out how the update schematic and update PCB from schematic and vice versa works, or the best way to use it, because I don't want to click the auto button and it screw up a whole bunch of stuff for me and I may not understand why, so but yeah, thanks for hanging out and watching. If you want to see more, check out the description. You know where all the links are, so I'm sure you can figure it out. But yeah, that'll be it. Bye!